Oh. You're not behaving. Why aren't you behaving? You're behaving. Okay. Okay, I'm gonna go ahead and get started. We are gonna be going through, my goal is 13.1 through 13.5 today. However, 13.1 through 13.4 is the crux of what we're going over. 13.5 just kind of introduces the types of chemical reactions that organic molecules and biological molecules undergo, which we'll go into more depth on Thursday. So, let's get into the information for today. So today is going to focus on alkenes and alkynes. From the first chapter, if you'll recall, the functional group for an alkene is that it has a double bond involved, a carbon double bond carbon specifically. Whereas the functional group for an alkyne is a carbon triple bond carbon. So that is going back to our definitions of what the functional groups are. Now, we can also have cycloalkenes. Well, if I could spell. Which are going to be functional groups the functional group is still going to be a C double bond C, but it's going to occur in a cyclic structure. Now we can have cycloalkynes, but cycloalkynes are pretty rare. So we'll mainly focus on alkenes, alkynes, and cycloalkenes in this particular series. Alkenes, alkynes, they're considered to be unsaturated. So before I come back, and I'll come back and fill in this a little bit more, but let's talk about a new set of terms, and that is saturated compared to unsaturated. Saturated is going to be a compound where the carbons have 4 bonds, have 4 single bonds specifically. Unsaturated is the term we use to describe alkenes and alkynes because it is a compound that has a double bond or triple bond. Folks, you've actually have experience, most likely, in hearing these terms, saturated and unsaturated, when it comes to butters and oil-based butters. Saturated fats are going to be fats that have carbons with 4 single bonds, whereas an unsaturated fat is going to have at least 1 double bond in there. So these sets of terms are the terms that you should already be familiar with, but they're related to something that you have hands-on experience. So alkenes have the functional group C double bond C. The ending of an alkene name is going to be ENE. That's how we distinguish it from an alkane. An alkane ended in ANE, an alkene ends in ENE, and the ending for an alkyne is YNE. Any questions about the difference between an alkane, alkene, alkyne, and the term saturated and unsaturated? So far, it's just terminology. Okay, so let's get into naming alkenes and alkynes. And this is where we're going to get into the major discussion for today. This is what we're going to spend the majority of our time on today, is naming of alkenes and alkynes. Okay, so step number 1. Is to name the parent compound. The parent compound will be the longest chain containing the multiple bond. So if you go back to what was step 1 to begin with, in our previous discussion for naming alkanes, it was to find the longest chain. The only difference now from what you already were doing is that it contains the multiple bond. Now, if there is more than one multiple bond, then you will use the appropriate prefix before the ending. So in other words, if it's 2, then it would be a di as the prefix. If it's 3, it would be a tri as the prefix. So if we're talking about an alkene with 1 double bond, it means that it's going to get just the ending ENE. If it's got two double bonds, it's going to have the ending diene, because I'm telling you there are two multiple double bonds. Three double bonds, would be triene, and so on and so forth. Step 2 is to number the carbon atoms so that the multiple bond is the lowest numbers possible, or have the lowest numbers possible. Now, there is one caveat, and that is if the multiple bond is equidistant from the two ends, the number so that the substituent gets the lowest number. If we are talking about a cycloalkene, then the double bond will occur between carbons 1 and 2. Step 3 is to write the full name. Assigning numbers to the branch substituents, and to the double bond. Or triple bond. As always, commas are used to separate numbers. Dashes are used to separate numbers from words. Okay, now that we got the steps down, we're going to practice it. So let's take.
Can you scroll it down just a little?
Okay. Step number 1 is to find the longest chain that includes the double bond. The longest chain that includes the double bond is 5-carbon chain. A 5-carbon chain has the prefix pent. So we know that this is going to be a pentene because it has a double bond in it. Now you got to tell me where that double bond is. So step number 2 says to start counting from the end closest to the double bond. So we would start counting from the right-hand side and move left. So this is 1 pentene. Let's look at another example. Step number 1 is to find the longest chain with the multiple bond. The longest chain with the multiple bond, we could go either north or south on this because both of those branches are the same. But it had to be this. So here's the difference. Before, when you were dealing with alkanes, we would have gone 1, 2, 3, 4, 5, 6, 7, because that was the longest chain. But now we're talking about an alkene. And with an alkene, the double bond has to be in the longest chain. So that's why we went 1, 2, 3, 4, 5, 6. Is because with an alkene, it has to be, the double bond has to be in the longest chain. Now, we're going to number it so that the double bond is the lowest number possible. So 1, 2, 3, 4, 5, 6. So the base name is going to be a 2-hexene. It's hexene because there are 6 carbons in the chain. It is 2-hexene because the double bond starts on carbon number 2. Now we need to name our substituent. Well, that is the propyl group. So it would be 3, let's see if I can do this without 3 propyl 2-hexene. How did I know that this was the propyl group? If you go back to Fig table, or figure 12.3, the propyl group is CH3, CH2, CH2, and that's where it connects to the main chain. So it was the propyl group because of that. Questions? Let's look at this structure. I see a cyclic group. So I know this is going to be cyclohexene because it's 6 carbons in that cyclic group. Now, to number this thing. We know, according to the rules, if you look back, when you're numbering a cyclic group, the double bond has to be carbon 1 and 2. So we have options here. We can go 1, 2, 3, 4, 5, 6, or we can go 1, 2, 3, 4, 5, 6. Should I number it using the blue numbers? Or should I number it using the red numbers? Red. Why?
This one.
Because not only have I got the double bond between 1 and 2, like I'm supposed to do, but now my substituent's the lowest number too. So this would be four methyl cyclohexene. Why didn't I put a number in there to tell you where the double bond was? Because it's what? Because it has to be on one. It's understood. Now, if there were multiple double bonds, we'd have to worry about it. So let's look at one of those multiple double bonds. I want to give you a moment and figure out which way to number this thing. Okay. So one option is 1, 2, 3, 4, 5, 6. The other option is 1, 2, 3, 4, 5, 6. Or another option is 1, 2, 3, 4, 5, 6. Which one makes the most sense? Blue, red, or purple? I've heard, okay, how many think blue? How many think red? How many think purple? It is purple. Why was it purple? Because not only do I have the double bonds at the lowest number, but the substituent's the lowest number too. Double bonds are more important, but in this particular case, while the double bond was the most important, I was also able to label it so that the substituent was the lowest number possible as well. So this one would be called 1-methyl one four cyclohexadiene. We're used to labeling substituents from the previous chapter. The new piece is that I had to tell you there is a double bond on the first carbon in the cyclic ring and a double bond on the fourth carbon in the cyclic ring, and hence the word diene. Questions? Yes.
Where's the second -1? Like if there's 1-methyl and then -1, where's that one coming from?
Again, I'm having to tell you where, it's the purple one. I'm having to tell you where the double bonds are. The double bond is on the first carbon, which is supposed to be representing that one. And it's on the fourth carbon. Once I figured out I needed to use the purple. Let's look at another example, and I want you to work through this one. Actually, I'll give you a couple to work through and then we'll come back and answer them. Okay, on the first one. You find the longest chain. Do I go up or down from this point to find the longest chain? You gotta go up. So that's the longest chain, which is a 6-carbon chain. So it's gonna be a hexene. Where do I start numbering? The right, the left, right. Why? Substituent will be the lowest. 1, 2, 3, 4, 5, 6. So it is a 3-hexene. Because that's where the double bond is. Now what else is in here? A methyl group. So this is 3-methyl 3-hexene. Any questions about that one? Okay, the longest chain is obvious in the next one. There was not any, hopefully no surprises. It is the entire straight piece. But which side do I start numbering from, left or right? Right, why? Because it didn't matter on the double bond. I would have a double bond at 1 and a double bond at 5, no matter which way I go. So since it didn't matter on the double bond, I've numbered it so that I'd get the lowest substituent. So 1, 2, 3, 4, 5, 6. So this is going to be 2-methyl 1,5-hexadiene. Questions? Okay, just like you can have isomers with alkanes, you can have isomers with alkenes. Let's just look at one of them. Let's look at C4H8. And let's determine the possible isomers of the alkene. What I do, folks, is I start the same way I did yesterday. C, and I draw 4 in a row. But this has a double bond in it. So I'm going to put the double bond in one location. And that's going to give me the first isomer of this butene. Now, unlike before where the next step would be to remove a alkyl group and move it around, I got to move around the double bond first. So yesterday we would take an alkyl group and we would move the alkyl group around. And then we would chop off a second alkyl group and move it around. But when you got a double bond, your first step is to move the double bonds around to get different ones. So this is one butene. Our next one would put the double bond between the second and third carbon. So it would be 2-butene. Now, if I kept moving the double bond around, would I create another isomer? No, this is not another isomer because this is also 1-butene. Because that's where the double bond was. So that's not an isomer that we haven't already created. So once I've moved my double bond, then I start moving methyl groups around. By chopping off one of them. So this would be 2-methyl, 1-butene. At first glance, have I created all possible isomers? At first glance, it looks like I've created all the isomers. But here's the thing. There is actually 2 versions of 2-butene. So I need to introduce a new concept. The introduction of a double bond because of the double bond's rigidity the introduction of a double bond creates cis and trans isomerization. This isomerization is not visible unless you incorporate or you use line structures. So we have options with a double bond present on that second carbon. we can either put the methyl groups on the same, on the opposite side of the double bond, or we can put the methyl groups on the same side of the double bond. If the methyl groups are on the opposite, or if the groups are on the opposite sides of the double bond, then it is a trans isomer. However, if the groups are on the same side of the double bond, then it is a cis isomer. So for 2-butene, we actually have two options. We have trans 2-butene and we have cis 2-butene. So this 2-butene here that we drew could actually be divided into two. The 2-butene that I circled up above could actually be divided into two. It can be called trans to butene or cis to butene. Folks, the trans butene to butene is actually more stable. Due to less steric hindrance. Than is the cis butene. So for this double bond, let's think of it as a generic Okay. So with respect to this, these are considered to be the ends. And these are considered to be the sides. Now, in order to have cis or trans, A cannot equal B, and E cannot equal D. In other words, they have to be different on the ends. The ends have to have different substituents to it. So let's just look at a couple of examples and we'll see which can have and which cannot have cis and trans. Let's take a butene and pentene. If I were to have this structure, cis and trans are not an option. Because the left-hand carbon has two hydrogens attached, or two of the same group attached. But if this 5-carbon structure exists, this one is going to be the cis isomer. And the reason is because there are two different groups attached to both sides of the double bond. This one is cis because the two big groups are on the same side. Whereas this one would be trans. Again, that we can have cis and trans because we have groups that are different on the carbon in the double bond. The groups have to be different. So let's look at some examples. Name the following compounds. Okay. So this first one, the longest chain was 6 carbons. We start numbering on the carbon closest to the double bond because it is the most important. So this is going to be a 4-methyl 2-hexene. But because it has a double bond, I got to see if it's cis or trans. Is the group at number 1 and the group at number 4 on the same side of the double bond or on opposite sides? Same. So we would add cis, and usually it's in italics, but obviously I can't do italics. So I'm going to cursive it, cis 4-methyl 2-hexene. The next one, the longest one, is either, you could have gone up or down on that piece. But it's includes all of that. We number so that the double bond gets the lowest number. That's our first option. So we'll number it going 1, 2, 3, 4, 5, 6, 7. So right off, whoopsies, I see this as a 5, 6, 5, 6 dimethyl 3-heptene. But because there's a double bond, I got to see, does it have cis or trans? Are the groups on the same side or on opposite sides of the double bond? They go opposite each other. So in this case, it's trans. 5, 6 dimethyl 3-heptene.
You're looking at those links.
So what I'm looking at to determine whether it's cis or trans is I'm specifically looking at this line and this line. See how they go opposite when I drew the 2 lines? Whereas in the previous one, I was looking at the 2 lines and they were on the same side. Did that answer your question?
Yeah.
Okay. Questions about cis-trans? Okay, so I think all we're going to get through is we're going to quickly discuss the properties of alkenes and alkynes. And what we can say is, for the most part, the properties mimic the alkane or the similar alkane. What I mean by that is we're talking low melting points, low boiling points, We're talking about it not being, insoluble in water. Due to London dispersion forces. We're talking that they are still flammable. So what is the difference? The difference is due to cis-trans isomerization. And basically, this difference causes different physical and biological activity. I already mentioned the fact that cis is usually less stable than trans. Well, if it's less stable, that's going to cause a different reactivity. And so the other thing that we can say is that due to the double bond, or triple bond, due to the multiple bond, let's do it that way, due to the multiple bond. Alkenes and alkynes are more reactive than alkanes. Folks, this comes back to that dietary thing I mentioned at the very beginning. When the alkenes and alkynes are considered to be saturated, unsaturated, whereas alkanes are saturated. For the longest time, we've always said, go look for unsaturated butters and oils. They're healthier. I mean, there's always question. Don't get me wrong. But why? Well, the reason comes back to that double bond. If it's saturated, folks, there's hardly any reactivity that can go on. It's gonna sit there and stare at you. If it's saturated, it has two reactions it can undergo: combustion or halogenation. That's it. But as we're going to discuss on Thursday, if it's unsaturated, now you have a lot more possibilities for reactions, and reactions require energy. So you use energy to digest and everything else, and that's why they say it's better. So, any questions about today's information? Again, I know you probably get tired of me checking in, but I like to check in ever so often, or once a week at least. Tell me what you need from me. Or is the process I'm working with here working for you? I'm always up for feedback. So,
Since we're working with me so far.
My homework really helps. Do a lot of problems.
well, and I will put together some homework. I'm gonna do that today. I'm gonna estimate what we're gonna get to on Thursday, so I may have to go in Thursday after class and edit it. But, I'm gonna go ahead and put the homework together that's due on Monday today, so that if you want to work on some of those homework problems, you can work on through at least the naming and cis-trans today. And then when we get to, reactions, that will be on Thursday. Do you like acting? Okay, because some people do, some people don't. I think it's a useful tool because it requires you to really learn how to view drawings and stuff like that, even more so than the textbook does. So,
Mine crashed on me last night, so,
oh dear.
yeah.
That I have no, when things crash, I am out of luck, because I know nothing about. I'm not computer illiterate, but, you know, they run those programs, so if there's an issue, you can always email me, but,
I gotta finish, but it does that a lot for me.
okay.
Goes to the-
Huh.
Could you take the learning subscription of homework too? Then I saw like what I get funded. What's going.
I will check it and
Yeah.
see. I'll have to go back and look at yours individually. Any other comments, questions? Keep talking to me, folks. That's the only way I know if I'm meeting your needs, is if you keep talking to me. Don't forget, you got 2 quizzes due by Thursday, but otherwise, I will see you Thursday morning.
Will you put quiz 3 and 4 Thursday?
Yes, I want to wait until after we go over the material, so I know what to put in those.
Yeah, you versus Q.
Thank you. Yeah, quiz 3 and 4 will be like 5 questions. They're not gonna be tough like the homework where you got multiple questions. They'll be short. Hi, Kayla, how are you? I'm good. At some point, please, you can email me times that you have available and I'll respond.
Okay.
I've got to get the card from Jamie each time somebody comes to see me, so you gotta let me know when you're coming.
Let you know. Okay, I'll email you.
Okay.